The biggest technological change that I see today, and for me, it's the biggest one in the history of humankind, is because now we're delegating decisions. So the PR review process and having agents build more and more code, it touches on the core of what I think is going to be our biggest challenge going forward. And that is, how do you take what these models do and embed them into processes to make the entire thing more efficient? It usually doesn't work that well when you take something and you plug it into an old process.
Hello everyone and welcome to a new episode of AI Without Borders. I'm thrilled to have Alex Jaimes. Alex is currently head of Conversational AI and Search at JPMorgan Chase. He was previously Chief AI Officer at Dataminr, but most importantly for this podcast, Alex is originally from Colombia. Alex, welcome. It's great to have you here.
Thank you. I'm very happy to be here.
So I wanted to start with the news of the month. Anthropic recently released a blog post called When AI Builds Itself, and notes that although we are not there yet, we are getting closer, and they outline potential implications of that. What is your personal read and take on self-recursion?
So my thoughts on recursion, in particular with AI models, it's a very exciting area. And like a lot of stuff in AI, it's really not that new. If we go back many decades ago, there was this concept of genetic programming, genetic algorithms. And the idea was that algorithms could mimic the way cells reproduce and organisms reproduce. And so there's a lot of self-improvement in that sense. So the concepts are fairly old. But if we look at what AI models do today, I think for me, it's a no-brainer that this idea of recursion and self-improvement is very possible. And like everything, there's a scope, there's a range of things that they can do today, and there are things that for which we're still far away. But I think that's really what the future is going to look like, and I don't think it's something that can be stopped. I think it's naive to think that we can stop development of these models or any particular technique. It's never worked in the past where somebody says, let's stop doing this because it's not safe, right? Maybe it creates the opposite effect where people then say, oh, wait, there's something really interesting here. Let's do more of it. So I think it's definitely something that we will see. And again, if we try to do it today with existing models, conceptually, it's possible to have models that create stuff and that improve, because at the end of the day, it's all data, it's all probabilistic. So I think it is very likely.
And I know that making predictions in this market might be a bit naive, but still will ask you, if that self-recursion happens, what are some of the implications? And focusing here on founders, one of the things that people commonly say to founders is you should build thinking about the next generation of models. And in this case, if you're starting to think about a future where we have self-recursion, what do you think it's worth building and not building in that world?
So my opinion in terms of what we should do and how startups should think about it, and founders and what does the future look like if we have models that are self-learning and self-improving, you kind of have to look at extremes, right? So in one extreme, you could say, well, I just type a prompt and I have a model that will do everything and it'll continue to improve over time. In reality, most applications and most systems that are used that become consumer products or B2B products or whatever that is, have many components, right? It's not just a single thing. It's not a single entity. It's many components, and these components have different purposes and they do different things. So within that range of features that you have in a product or functionalities, there are going to be places where you want things to improve, and there will be places where you don't want things to improve. You build something and you want it to stay as it is and to be static. And one thing that's interesting about this is humans are not very good at change, right? We don't like when we use a product and then it changes overnight. So imagine if you built a product and then you're a consumer and you're using it, and then the next day it's completely different because it improved so much by itself that the next day it's a completely different product based on, whether your own usage or usage from other users. That's not really going to work, right? So there's a disconnect there. So there are things where we want stability, and not only in terms of the actual end product, but in terms of the components, right? There are, again, things or components of the system that serve a purpose and they do what they're supposed to, and there's no need to continue to improve them. Once they're done, they're done. In that sense, it's a bit more like engineering. There are components that are more like engineering that you don't need to improve them. So this notion that everything will have to continuously improve, I think is false. I don't think that's really how the world is going to work. There are going to be things that you want to improve, but at some point you want to reach a point of stability where, okay, this does exactly what I need it to do. I don't need a better screwdriver, right? I have an electric screwdriver. It's fast enough. It's powerful enough. That's it. Unless you change the paradigm, you say, well, you don't need screws anymore, but that's a completely different thing. So I think it has to be looked at within that context of what it is that needs improvement over time and what doesn't. So in the areas where you do need improvement, I think that's where you have to be smart and see, what is the upper bound of those improvements? And, to give you an example, if you build a model to recognize writing, right? Most reasonable models will do fairly well, and there's no reason to continue to improve them. Like, it's done. It's a solved problem in some contexts, right? Whereas for some other tasks, you need significant improvements over time, and they will change and maybe become more and more personalized. But the human element, I think, is one of the key things. How do we get these models to do what they're supposed to and improve in ways that can supplement our the interactions with humans and with other systems? That's the part that's more complex and more interesting to me than just the models by themselves improving and doing stuff that may not necessarily bring any actual benefit. So it's a lot of it is about value. What is the value added if you have something that improves versus if it doesn't improve it just does exactly what it's supposed to do.
I'm gonna get in a tangential here, but one of the topics that I've been personally fascinated about is generative UI, which is that promised future that now you can use UI like AI to generate personalized user interfaces. But I wanted to get your take on it that now that you're mentioning that point around A, human adoption, and B, some things actually are not great that they are changing all the time.
I think it's fantastic for prototyping. You can create stuff very quickly, very easily. But there's something about our brains that doesn't like change. Our brains are not used to having everything suddenly change. The physical world is mainly static in the sense that, things move and so on and so forth, but they don't change overnight. And it takes us a long time to learn how to navigate the physical world. And I think in some ways, our digital lives mimic that physical world. I don't know about you, but my tabs are usually a mess. I have tabs all over the place, but my brain helps me because I remember where they are physically on the screen. Like I remember, okay, the one on the left is this when I go, this one on the right, and the same for my desktop. Like I have things laid out in a way that my brain remembers locations because our brain is very good at remembering locations. And there are a bunch of other things that our brain is good at remembering. So if we start creating things that are continuously changing, it's just going to create confusion. I don't think we're ready. Humans are not ready for that level of customization where it's going to continuously change. And we don't want it to. We don't need it to. So I think maybe, it's the kind of thing where it gets personalized up to a certain point, but then it becomes stable. And how long does it take for those changes to become stable is hard to say. It's like, you buy a watch because you like the way it looks. You don't want to wake up every morning and have a completely different watch, right? Or have a completely different computer with the layout of the keyboard is going to be different. You don't want that. You want it to be stable. And it takes you, whatever it is you're using, it's going to take you some time to get used to it and to learn it. Once you learn it, you don't want it to change. So it's sort of this friction between, maybe ease of learning how to use something to the point where it becomes stable enough and you've learned it and then you're comfortable and then you don't want it to change, or something that, changes so much at the beginning that it's harder to learn, but then it's closer to perfection of what it is that you actually want to do. So I think we'll see a range of those things, but in general, I don't see a world where everything will be generated. Of course, there are many applications where, generations of things in real time on the fly are extremely useful. You can think of advertising. You want to see ads that are relevant specifically to your moment and your situation. They're very personalized, and the more personalized, the better, because then they're more valuable to you, and that makes sense. But it's the same reason we like, a sitcom or a TV show. We want to see the same characters. We like consistency. So I think that's a tough one. Like we're going to have to have a deeper understanding of the human brain and how we kind of connect with these systems to make those two things achieve the maximum value. And again, it depends a lot on the situation, but for the most part, I think humans are, used to habits and it's a very well-known thing, in psychology and behavioral psychology.
End of the spectrum. Now that we have more agents doing work for us, there is another camp of people who are saying that we're going to become more headless, meaning you will give your agent a call, the agent will go there and do the job. Instead of you opening your 20 tabs that you used to do, it is the agent that's going to be navigating. And the amount of interaction that you have with the UI will be minimized just to approve the agent work.
Yeah, I think no one knows the answer. And, I'd like to imagine a world where we continue delegating the lower level tasks to agents and doing the heavier lifting in terms of cognitive tasks and focusing on the things that matter. And it's a little bit like, again, our daily life. Our brain kind of lets us do certain things automatically. When we walk, we're not thinking about the next step. We do it automatically. When we run, we're not thinking about everything. We're often, like when I run, I'm often thinking about things that have nothing to do with running, like most of the time. And so I think with agents and AI, it's kind of a similar situation where as we get more used to these tools, the level of things that we do is just going to be higher and higher and higher. And it's not new in the sense that we've been doing this forever, since the beginning of technology, where we delegate things to technology. And I talked about this in my TED talk a few years ago, where I kind of said, the biggest change now, the biggest technological change that I see today, and for me, it's the biggest one in the history of humankind, is because now we're delegating decisions. And I put that in 3 categories. One is where we just say, go do this, and it's fully automated. The system, the AI model does everything fully autonomously. The second one is where we, the AI model or the system is doing stuff and we're sort of supervising it closely, right? And one example of this might be self-driving cars today, depending on what level you're looking at, where you're sitting by the wheel and you're ready to take over whenever you need to. That doesn't work that well in practice, but that's the idea. And the third one, where the AI model or the system is just recommending stuff to you and then you're making decisions. But in the fully automated one, you're delegating decisions completely. And I think that's where we're seeing a big change, where we're delegating more and more of those decisions to AI systems, what you write, how do you develop the code, et cetera, et cetera. But there will still be many, many decisions that we take on a daily basis that matter. So my hope is that as we continue to see progress in these models and they become more powerful, we become smarter in a way. There's the other hypotheses, and I don't know if you've read books by Nicholas Carr, but this was written years ago, and he was, based on some studies, and part of the thesis was, the hypothesis was, Google is making us stupid. And the idea was it was making us stupid because you're able to find anything you want by just searching the web. So you don't need to remember anymore, right? And I think we're reaching a similar point with AI models and agents, where you don't need to think too much. You become lazier. You can just say what you want, but you don't have to specify it as much as you did. When you were writing code before these coding agents existed, you had to think about every single little thing. Now you can actually build an application by just writing a text prompt, and you don't need to worry about any of those details. And I think that's good and bad. I think it depends on how we use it. It makes things faster. And in general, I think that the ability to create a lot of these technical tools faster and at lower costs means that there's more access to things, and that lowers costs in general. So it gives more people access to things. So in general, I think it's positive. But in terms of, how we use our brains to do stuff, that remains to be seen.
I think that's a great point. And I've been spending a good amount of my time now building our internal tooling at the fund that I work. And one of the partners here, one of the things that he's been warning me as I build this is put some friction in the process, because to your point, what we don't want to do is delegate your thinking. You want it to augment and definitely accelerate that research. And there are certain friction points that even become like a feature of the product rather than the opposite to your points.
Yeah, I think it forces us to be more thoughtful about where we put our energy, right? Because if we don't have to think about every step we take, it frees us up about, in terms of letting us think about many other things. So it's kind of similar. And so it places a higher bar in us, in that gives us that responsibility. Like anybody can build whatever app. So to build a better app, you really have to think hard. You have to do a lot more than just do it. And you have to experiment. You have to build multiple apps, do multiple iterations until you get something that's really amazing. So if you think of it that way, what that will do is it'll actually increase the quality of the stuff that's created, because if everybody can create the same thing, you have to work harder to create something really unique. And that means you have to think more. If you just do the simple basic prompt, your thing is going to look like somebody else's and like somebody else's, somebody else's. So the only way to excel is going to be to work harder and harder and harder and do more of that high level thinking in whatever it is that you're doing.
I agree that that judgment on what to do is going to become it's becoming one of the core skills. And switching gears, on the past month, we've seen an increased adoption of open source models. Companies like Cursor, Harvey have been sharing that they've been post-training open weights models and seeing great increase in performance. What is your take on the future of open source?
Right after ChatGPT launched, I mean, I knew it was a critical moment in tech. I didn't realize how big it was because I think I posted on LinkedIn, the day it launched that it was the biggest innovation in the last 10 years or something. Clearly, it was much bigger than that. But when the Llama models leaked soon after that, I immediately knew, like, okay, the cat is out of the bag. There are going to be lots of models out there. And it's been a very persistent topic in my talks over the last few years, again, since the launch of ChatGPT, this idea that these open source models or open weight models will continue to exist and they will be really important. And in fact, that's a big part of what I did at Dataminr. And I published this in a blog about 3 years ago where I said, okay, seeing what I'm seeing today, this is my opinion on what we should do, and this is our strategy. And what I outlined as the strategy back then was we're going to take open source models, use our proprietary data, and we're going to fine tune and adapt those models for our specific scenarios and use cases. And that's what we're going to do. And there are many advantages to that. One of them is performance in terms of accuracy. And it turns out, since then, we've seen increasingly more and more companies do the same thing and more people do the same thing. And it's become clear that if you take an open weight model and you adapt it with your own data, you will often get better performance than any frontier model. So that's number one. Number two is cost, right? It's way cheaper to do that than it is to run a frontier model. Although the costs have significantly dropped over the last 3 years, it's still a lot more expensive to run one of the large frontier models than it is to run a smaller, adapted or fine-tuned open weight model. The third one is privacy. You own the model, you can do whatever you want with it, you have more control. And then the fourth one is also pretty important, and it's latency. If you're using a smaller model that is more specific to your use case, it's going to run faster, so it uses less compute. But latency is a critical aspect, especially when it comes to agents. 3 years ago, it was critical within what we were doing at Dataminr, which is real-time event detection. But now what a lot of organizations are seeing is that it's really important when you're building agents and having agents talk to each other and reacting to human inputs, et cetera, et cetera. So all of those factors, I think, remain really important. And I don't think anything has changed. I think the only thing that's changed is more people discovering that if you take open weight models and you adapt them, you get better results than if you use frontier models. Now, there are some exceptions, and some of those exceptions have to do with more complex use cases and where those models are really large and they can do a lot of things. And again, it really depends on the application. The large frontier models can do many different things. Most applications require models to do only one thing or two things or three things within a specific domain. So the example I always give is like, you can take a limo to the airport that has a jacuzzi inside, has a disco ball, has, 40 speakers, it has all this stuff. Or you can take a regular yellow taxi to the airport. And if you take the limo with a disco ball, you'll pay maybe $1,000. If you take the taxi, you'll pay $100. At the end of the day, they both take you to the same place. So which one do you want and which one do you need? So the frontier model, the challenge is in many scenarios, you have all of this additional functionality that you're not really leveraging. And so you're paying a lot of extra money for stuff that you don't need, and you're paying in latency, and you may get ahead in terms of accuracy, right? So anyway, I think it's a trend that will continue. I think we've only seen the tip of the iceberg in terms of open source models. And I think we'll see more companies develop them. I think one of the challenges that has existed for a while is the business model behind the companies building these models. It takes a lot of energy, effort, and capital to build these open source models and release them. And so there have to be financial incentives for companies to do them, or for governments, that would say, okay, I'm going to build these models and release them. But I've seen a few of these initiatives recently, and I think they will continue because I think it is, for many applications, it is the way to go. And even if they're behind sometimes in terms of performance versus frontier models, that difference almost doesn't matter depending on what you're doing. Whether it's 6 months behind or 3 months or 9 months may not matter depending on what you need. Because if it solves the problem you need today and for the next 1 or 2 years, then that's enough and it's fine. You don't need the frontier model.
And how big of a threat do you think this open source future is to the big labs? I know that you mentioned the point that some use cases will demand the frontier, but how far are we to reaching that a point where 95% of the tasks you can do with the closed source models that are 95% behind? And really, in that world where the really tail end is the ones that you need the frontier, that's kind of a threat to the long term success of these businesses, especially considering the magnitudes of capex that's being spend.
Yeah, so I think they will coexist. I don't really view them as, this against that. There's no free lunch, right? So depending on where you are in your AI journey and what it is that you want to do, going with a frontier model may be the best option versus fine-tuning a model. For example, if you're building a company from scratch, you're not going to have data to start with. You're not going to have the team to, that knows how to fine-tune a model necessarily. Even if it's 1 or 2 people, you may want to devote your resources elsewhere, building the product, building the app, et cetera, et cetera. So for many of these situations, you're better off just plugging into one of the frontier models. It becomes more of a critical point when you start scaling and the costs start going up and you have a large number of customers or users, and then latency becomes an issue. And there's no free lunch, meaning, with the frontier models where you use, these public models, you can get started immediately. There's no upfront investment, even though the cost per call is a lot higher than with the open source models, but you get results immediately. You don't need much. You just need an API call to build an application. For the open source models, you're going to have to invest in fine-tuning them and getting them to work, and you have to do a lot of work to get them to perform as well as the frontier models. So you invest a lot more in that effort at the beginning, but then your costs over time and inference will be lower. So I think what ends up happening is you're going to have, there are many, there are millions and millions of small businesses that are never going to be fine-tuning models. They're not, it's not their business. They just want to plug and play kind of thing. So for those, plugging into an API is the easiest and most reasonable way of doing it, or a third-party application that then uses one of these APIs, right? For the larger companies as they scale, maybe using these open source models and fine-tuning them is the way to go. So I think a typical journey for a lot of startups might be they start with the large frontier models using APIs because it's easy to build a prototype, easy to build a demo. And then as they start scaling and they start seeing the bills for token use going up, they start optimizing. And they say, okay, well, now we can replace this particular thing with a smaller open weight model, maybe without any fine tuning. Maybe that's good enough. And the ecosystem then becomes a little more complex because then you're calling multiple models, et cetera, et cetera. But that's saving you a lot of money. And money at some point starts to matter, right? Maybe initially it doesn't matter that much. You just want to capture market share. Maybe speed is what matters the most. So there's always going to be, an inflection point wherever you are. And it's a bit similar to cloud. If you're big enough as an enterprise, at some point, paying cloud is less cost effective than building your own cloud. So it not exactly the same scale, but so I think it's going to be a mix. And I do think as more and more applications use this, and part of this use these AI models, and part of it is consumer and user expectations. As we get more used to using the ChatGPTs of the world and the Geminis, et cetera, or the Claudes, the more that we're going to expect those kinds of interactions from every application that we use. And so I think that only means that the consumption of this infrastructure will continue to increase. But because there will be many optimizations over time, I don't know how big the bottleneck is going to be, right? It's anybody's guess. But I also think we are, and veering off topic a little bit, I think we're at the point where everyone's so excited about AI and the capabilities that everyone's like, use it, use as many tokens as possible. And I think what will happen is people start getting the bills and companies start getting the bills. They're going to start questioning, wait a minute, what is my return on investment here? What am I actually getting out of this? And then they're going to start tightening the screws and say, wait, let's not spend so much money without really understanding where the benefits are. So there's like a honeymoon period right now where everyone's spending and spending and spending. So I think it's going to be kind of like, we're at this point where it's increasing like this, and then it's going to start plateauing. And then it's going to lower for many companies and potentially individuals. But then in aggregate, it'll continue to go up because once it gets to this point of the plateau, more people will jump on board and start using it. So overall, I do see a trend going up. I think the big question is how steep is that curve? How fast is it going to? How fast is demand going to continue to grow? Is it going to slow down? Is it going to speed up? It's anybody's guess.
Yeah, no, hard one to predict, but definitely one of the most I find that to be the one of the most fascinating questions: the supply and demand imbalance that we'll see or dot as you were saying. And jumping gears, so you've been now leading or taking high positions at several large organizations. What's your personal framework or first principle thinking as it relates to the very big question around what should you buy and what should you build internally?
I think the biggest question that I ask myself is about strategic value. Like, is it something strategic to what you're doing? And does it add significant value to own it and build it? And that value comes in different forms, but in many cases, that value relates to, if you're building a product that is consumer facing, to that customer experience. Are you going to build something that's really unique? And by building it yourself, are you going to be able to offer better value than if you take something that's off the shelf? That's a key question. And as I said before, again, with this as well, there's no free lunch. So if you want something quick and fast, then buying is the right way to do it. Obviously, one of the challenges today with the speed of innovation and the way things are changing is that a lot of the vendors that we see for all kinds of things are fairly new companies, that didn't exist even two years ago, in some cases even a year ago. So it's a lot harder to pick and decide whether you buy or build because you don't even know exactly what the world is going to look like in a year, right? But I think the biggest question is the strategic value. So if it has strategic value in terms of IP or in terms of the user experience or the data that you're using, it's sensitive data, you don't want to send it out to a third party, or related to that, if what you're building is unique and none of the solutions out there can actually deliver exactly what you need, then you have to build it. So it's never a single dimension. I think it's a bunch of different factors that you look at. And that's what I typically do. I like to actually, in most cases, it's like a competitive analysis. I create a chart to look at the different factors to try to figure out, out of the options that are there, which ones make sense and which ones don't. And when you're buying stuff, you need to look at risk, in terms of cybersecurity. You need to look at risk that the company is going to be there in 2 years. If it's a startup, how big is the company? Can they handle, if you're using something that's critical in production, can they handle an incident? Do they have the team? Even if the technology is the best. So sometimes you may want to say, yeah, we'll use this particular company, but do it slowly or use it only for stuff that's not critical. Right. And as they grow and you see them mature, then you start plugging it in more and more. And I think that's a pretty natural kind of progression. But I think the main thing, aside what I said in terms of, deciding what to do, is understanding that the ecosystem keeps changing. So I think it's less about, build versus buy, and it's more about how do you leverage the best of those worlds and build internal processes and platforms that allow you to plug into a vendor when you need it and allow you to use your own things when you need it in a way that's really easy to swap things in and out and experiment. I think, in terms of AI, a lot of it is experimentation. You can't measure stuff without actually experimenting most of the time. With traditional software, you kind of, what you see is what you get. But with AI models, you have to experiment. You have to measure performance. And whatever worked for you now, especially if you're scaling quickly, may not work 6 months from now. So if your wiring is too rigid and your processes are too rigid, that's going to be a problem. So at a macro level, that's a more important thing to look at than specifically for one thing, whether you buy or build. So it's looking at the entire ecosystem and all the processes around it, and how do those things fit into your process. So you might see a product that is fantastic to buy, but it doesn't really fit into your internal processes. So then it's like, okay, I'm better off building it than buying it.
And given to your comment on how fast things are changing, how far into the future are you able to plan today? Like at a startup, even at times, given how everything's changing, you can only plan maybe 3 months ahead. It's so hard to predict nowadays what's going to happen in 2 years. But at the same time,
yeah, so I've always viewed it as a mix, and I try to have projects within my org and the companies where I work in 3 categories: short, medium, and long term. And this depends a lot on the company. for a small startup, short, medium, and long term mean very different things than for a large enterprise, where, for a startup, short might be 2 weeks, right? For a large company, short term can be 3 months because it takes longer, because there are more systems, there's more compliance, whatever it is. You have larger scales, you have to make sure things work, et cetera, et cetera. Startups can take more risks. So the timeframes differ depending on the size of the company and the space you move in. What is the application domain? But I generally like to think in terms of those three, kind of short, medium, and long term. And I think keeping in mind what I said earlier about human behavior and expectations, you can't really change everything overnight, and if you look at, and it's a little weird, to be honest, right? When we think of most of the successful consumer products that we use, they mostly don't change very much over many, many years, right? I mean, they change features here and there, but most of those changes tend to be invisible or minor for the most part. And we can think of many, many applications where that is the case. I mean, think of, just to not go too far, think of Google search, right? For decades, the search bar was pretty much the same. And they ran, millions of experiments with, where they were looking at the size of the box and the pixels and the colors and tuning the algorithms and all that. But most of those changes were not that visible to the consumer. They were kind of underground and improving every single time. And it goes back to what I said earlier, that people don't really like change that much. So when you're making a big change to any application, you have to take those factors into account. So what that means is, if it's an established business with a large customer base, I don't think it's that easy to just make a lot of changes very quickly. And so the planning cycles are longer than they are with a startup, where you're just testing the market and trying to figure out what the right things are, et cetera, et cetera. So the timeframes change significantly depending on what you're doing and what the space is.
That flexibility, I think, is needed today. And going back to a point that we raised before around what you delegate and what you not, one of the things I've been hearing across engineering leaders is that as we have more agents writing a higher percentage of the code, the bottleneck is becoming how fast humans can review the PRs. And there are like two kinds of people that I've been hearing. One that believe still there is a human that's needed to review those PRs. And there is another camp that like, both today or in the very near future, models will just get so good that they are going to be able to reliably do that PR review process. Do you have any take of that? And even are you starting to see that bottleneck happen as you get more agents writing a higher percentage of code?
So the PR review process and having agents build more and more code, and the bottlenecks that that implies, because then humans have to review the code. I think it's a really interesting question, and I think it kind of touches on the core of what I think is going to be our biggest challenge going forward. And that is, how do you take what these models do and embed them into processes to make the entire thing more efficient? And what that means is that you have to change the processes. It usually doesn't work that well when you take something and you plug it into an old process, right? And so I think we're going to continue to see a transformation where, on one hand, that's what we do. We take agents that write code and then we embed them in the in an existing process, and then the bottlenecks are created because we haven't changed the rest of the process. And I think as we do this, as we continue to experiment, we'll find ways to improve those processes and how these things are connected. So that's on one hand. And on the other hand, I think there's always a notion, sometimes we tend to think of everything in a single category, but in reality, most production systems involve many different kinds of things, right? And they involve all kinds of components, some that are critical, some that are not, some that are sensitive, some that are not. So I think for some of those that are less sensitive, or some parts of an application or an application within a large organization, there are things where the cost of errors is low or not very significant, where you're willing to take higher risks. So for those, automated reviews may be sufficient. You just, you have an agent build the stuff, you have another agent review, and you're comfortable and you're fine. For things that are higher stakes, where the errors are more significant and more important, I think for those, you're going to need human review. And then the question is, how do you do that in a way that's more efficient and that is going to lower the probability of those errors? So again, it's a range between the things that matter less and the things that really matter. And in the TED talk that I did a couple of years ago, I gave an example of, if you have one of those robo vacuums, for the most part, it's very low risk. You just let it run and do it fully automatically, right? You press the button and it automatically will vacuum your entire apartment, and it's fine. It's not going to, do anything necessarily bad. But there are other scenarios where, yeah, if it's a self-driving car, you need to do a lot more testing, right? You don't want to just blindly press the button and say, oh, let's see what it does. So that's one way of looking at it. So for the vacuum, maybe you can do fully automated, have a model generate the code and have another check it. And if it makes, one of the worst things that can happen is it gets stuck. Another example is, there's some sort of mess on the floor. The dog pooped and it just goes over the poop and spreads it all over the apartment. And all these videos of that on YouTube. But it's not a major thing compared to, an autonomous vehicle, right? So I think it's going to be a combination of those. And the key is going to be, and the question is, how are organizations going to manage these different levels of risks, and how are they going to figure out where to put more guardrails and where they're going to put fewer guardrails in terms of human intervention. And that's the fascinating question. Like, how do we optimize that collaboration between humans and AI models? And interestingly enough, it's not only in that scenario of code reviews, it's also in terms of building the models themselves and testing their performance and using them in almost anything. And the better that you're able to combine those two things, the stronger your system will be and the application will be.
I think that category point is great. And to close by, I wanted to ask you about one of the most exciting trends that people are speaking about these days, which is continual learning. The idea that models should be able to learn after they are trained and deployed without forgetting what they already know. Wanted to get your take if you think this is really going to be the next frontier, if it's going to be as big as people expected or actually a bit overblown, and any misconceptions.
So continuous learning is a very interesting topic, because I think in certain scenarios, it makes a lot of sense and you want to do it. At the same time, the concepts are really quite old. Back in the late 90s, early 2000s, there, in search and image retrieval, there's this idea of relevance feedback, where the idea was, as you're retrieving stuff and you're clicking on it, it's learning, what to rank. And of course, that's the basis for many of the algorithms used in search, right? The problem with some of those approaches is, depending on the application, first of all, you don't need continuous learning in some applications. And second, it may not converge. It may just run away and do the wrong thing. And so I think there's still work to be done there to really understand how to limit and how to make sure that these algorithms or these models stay within their bounds and they learn the right things as opposed to the wrong things. And then, that gets complicated, because then you get into ethics and a bunch of other factors that would have to be taken into account, the context in which they're being used, et cetera, et cetera. And I think that's an active area of research where there's still a lot of gaps, I think. And so that's a very interesting one, because it speaks to something that I've been always passionate about. It's it's kind of human-centered AI or human-centered technology, where for those things to succeed, we really need to understand human behavior and how these systems interact in a world where humans exist as well as AI models. And what we know today is many of these models in isolation will do whatever we tell them to, and based on whatever goals we give them, they'll cheat and they'll do whatever it is they need to do to achieve those goals. And so this is known as the alignment problem, where getting models aligned to do what you want them to do within an ethical framework, within a social framework, within a framework of permissions, et cetera, is really hard, because we're not even able to express what those limitations are. But to me, that's a very exciting area where, again, I think in certain applications, it makes a lot of sense. And we'll see lots of interesting things over the coming years.
And with that intriguing note, Alex, really enjoyed the conversations. I appreciate you joining me.
Thank you so much. I really enjoyed it as well. Really appreciate it.